Welcome. We are Team 10 and today we will be presenting our project, the Acoustic Wildlife Monitoring of Bats. To begin with, as we know, bats have often been linked to various viruses that have impacted humans, most recently COVID-19. However, bats are also essential elements of the natural ecosystems that they inhabit, as they are pollinators, and so conservation efforts are also very important. For both these issues, more information is required about bat species and their habitats. The problem arises in the fact that collecting such data manually is complex, as the habitats that these bats live in, caves and rainforests, are very difficult to navigate. Our project aims to solve this information problem. Firstly, we have developed an AI model that can automatically classify 8 bat species based on their audio calls. This AI model was developed using data provided by the WWF from our co-advisor from the industry, Dr. Judas. This AI model is then deployed on the edge in their bat habitats that communicates any detections to our application server, which then presents this information using a user-friendly web portal for our researchers. This can be seen more clearly in this following diagram. Our edge device is connected to a microphone that performs the automatic bat species classification in the habitats and communicates any detections over the LoRaWAN network protocol to our central LoRaWAN gateway. Our LoRaWAN gateway then forwards any messages to our application server through the Things Network MQTT broker. This uses the MQTT network protocol to communicate our detections, as it is event-driven. These detections are then stored in a database and presented to our researchers using the user-friendly web portal. In terms of the innovative aspects of our project, our bat classifier is unique in the fact that it uses audio-based deep learning, Middle Eastern data, and that our performance has exceeded the literature at 97.51% accuracy. Furthermore, the web portal that we are developing has not been done before, and the hardware benchmarking that we have done will help this project be easily extendable. We will now continue with the various aspects of our project.
We have chosen the LoRaWAN network protocol to relay information from the edge device to the cloud-based server. LoRaWAN is an innovative approach to this communication problem as it has wide coverage and low power consumption, ideal for remote situations such as this. Indeed, research has indicated effective use of LoRaWAN for wildlife monitoring IoT applications. When any bat species is detected by the edge node, it will relay this information to the RBI gateway. The edge node connected to the high sampling microphone also features an ESP32 LoRaWAN device which relays information about the bat species detected to the LoRaWAN gateway. The LoRaWAN gateway can receive information from hundreds of edge nodes and use the event-driven MQTT protocol to publish the message to the Things Network's MQTT broker over TCP. The application server which subscribes to this event will subsequently receive information about the detected species.
This is the web portal that will be used by researchers for viewing bat detections. On the home page, the user can view a summary of all bat detections on the map. Over here, each bat detection is represented by a color-coded marker based on the bat species shown in the legend. Clicking on a particular marker will display more details of that specific detection in the form of a pop-up. The user is provided with various filtering capabilities. For example, the user can select one or multiple species that they would like to view the detections for. They can also limit the number of results to be displayed at a given time, or they could use a time range for the detections as well. So if we filter now, we can see the results on the map or in the table, and the header here shows what filters are exactly being used right now. Moving on, we also have a dashboard which provides a graphical summary of the detections in various forms. The pie chart shows the detections for each species as a proportion of all detections.
Here we have our system's total costs. In terms of the edge device, we have chosen the IPI3B Plus due to its comparable performance while minimizing the cost.
With regards to the social and industrial impact of our project, we firstly aim to increase the information on bat species in a non-invasive manner and also increase public awareness regarding bat population in the region. We also aim to improve ecological conservation efforts and epidemiological studies on bat-related viruses. This will support bat habitat management to reduce risk of viral exposures. We also aim to reduce the bat data collection cost and time to almost zero.
We would like to conclude with our achievements with this project so far. We have been published in 2 notable IEEE conferences, AI for Good and IoT AIS. We are also currently the top 25 finalists in the region for the Dell Technologies Envision the Future competition that we will complete in July. That concludes our presentation. Thank you for listening.